This video has the worked out solutions to the lesson 6-2 assignment, oral exercises number 1 through 15 odd. All of these problems involve fractions and multiplication. It's about multiplying fractions. To multiply fractions, you multiply the numerators and then multiply the denominators. Now you have two options. You can multiply first and then simplify the result. The second option is to simplify first and then multiply. For some problems, the first thing might be the easier, more efficient way, and for other problems, the second method might be easier and more efficient. The more of them that you do, the more that you'll learn which is the better approach. Now, question number 1 is 6/5 times 10/3. This is about multiplying fractions. If I use the first method, I multiply the numerators together first. 6 times 10 is 60. And multiply the denominators together. 5 times 3 is 15. And then simplify. 60 divided by 15 happens to be the whole number 4. Now, the same problem could be done using the second method. Let me rewrite the problem. 6/5 times 10/3. And I'll multiply these fractions using the second method, and we can then compare which one was faster, which one was more efficient. In the second method, you simplify the fractions first and then multiply. Simplifying fractions, we know from the last lesson, involves canceling common factors top and bottom. For example, in the top there's a 6, and in the bottom there's a 3. The 6 and the 3 can be reduced by dividing them both by 3. 6 divided by 3 makes 2, and 3 divided by 3 makes 1. Similarly, the 10 that's in the top and the 5 that's in the bottom reduce. 10 and 5 both divide by 5. 10 divided by 5 makes 2, and 5 divided by 5 makes 1. Now multiply. 2 times 2 is 4. 1 times 1 is 1, and 4 over 1 is better known as 4. Both methods get you to the same answer. Now, in your opinion, which one was faster, which one was more efficient? Next, number 3. -3/4 times 8/9. If I use the first method, I multiply first. -3 times 8 is -24 in the numerator. 4 times 9 is 36 in the denominator. And then simplify. 24 and 36 have a greatest common factor of 12. I can divide them both by 12. 24 divided by 12 makes 2, and 36 divided by 12 makes 3. The result is -2 over 3. Now let's compare that to the other method. Let me write the problem down again. And this time, we'll reduce first and then multiply. In the top, there's a 3, and at the bottom, there's a 9. Those are both divisible by 3. 3 divides by 3, creating 1. 9 divides by 3, creating 3. The 8 and the 4 reduce. They both divide by 4. 8 divided by 4 makes 2, and 4 divided by 4 makes 1. -1 times 2 is -2. And 1 times 3 is 3. Notice it's the same answer. Now, in your opinion, which way was the easier way? Which one was more efficient? Now, problem 5. 2 times x is 2x. In the bottom, x times 14 is 14x. Now simplify. The x in the top cancels the x in the bottom. 2 divides by 2 once, and 14 divides by 2 7 times. The result is 1 over 7. Alternatively, you could reduce first and then multiply. Let me write the problem down again. This time let's reduce first. The x in the top cancels the x in the bottom. 2 and 14 are both divisible by 2. 2 divided by 2 makes 1. 14 divided by 2 makes 7. There's a 1 in the top and a 7 in the bottom. Now, in your opinion, is one way easier than the other, or are they about the same? Problem 7. I have decided that I prefer reducing first because it makes the number smaller. So I'm going to look for reducing before I do the multiplying. So in number 7, the y squared in the top and the y squared in the bottom cancel each other away. The 6 and the 3 both divide by 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. In the top, 5 times 2 makes 10, and in the bottom, there is just a 1, and 10 over 1 is 10. Now, question 9. This particular problem has a group in parentheses, and everything in the parentheses is going to the second power. This time, you have to start to simplify first. You can't start canceling things until you first remove the parentheses to get the things released from the grouping symbol. So we're going to put our attention on this part of the problem and work that out. To raise a product to a power, you raise each factor to the power. Start with the 3 and raise it to the second power, then move to the letter C and raise it to the second power. 3 to the second power makes 9. C to the second power makes C squared. The second fraction I'll just copy down, 4 over C. At this point, I'm going to decide to do the canceling first. There's a single C in the bottom, which cancels one of these C's away, leaving one remaining. No other reducing can be done. 9 times 4 is 36, and there's a letter C with that 36. All right, number 11. Once again, there's a group with parentheses and an exponent. Now, should I expand that out, or would it be more efficient to leave it in its current form and move directly to the canceling? You have to examine the problem, look at patterns, look at what's there, and make a decision. For this particular problem, I want to leave it like it is, because I recognize that the x minus 1 factor in the bottom can cancel away one of these, leaving one of them left over. Now let's look at the 4 and the 8. Those are divisible by 4. 4 divided by 4 makes 1, and 8 divided by 4 makes 2. The final result has an x minus 1 in the top and the number 2 in the bottom. Next, number 13. I see a group of things in parentheses with the exponent on the outside of the parentheses. I need to raise each thing in the parentheses to that exponent. Start with the 5, then the A, and then the B. We're going to raise each of them to the second power. 5 to the second power is 25. A to the second is A squared. In the bottom, we have B to the second power. Okay, number 15 is a very similar situation. There is a whole bunch of stuff in the parentheses, and it's all being squared. So you want to square everything in the parentheses, starting with the negative, then the C squared, and then the 3. All right, a negative squared. Remember that a negative is really the same thing as negative 1. And squaring it means to times it by itself. Negative 1 times negative 1 is positive 1. A negative times a negative is equal to a positive. So when I have a negative sign and I square it, I end up getting a positive result. Now the C squared squared makes C to the 4th power. C squared times another C squared is C to the 4th. All right, down in the bottom, the number 3 squared makes 9. Recall that every one of these fractions in which there was a variable in the denominator will have restrictions. But if you remember the notes that we took, we're not going to write the restrictions any longer unless the directions specifically ask us to. This concludes the video.